Hello students, in part 1 of my video we discussed about sequence and the series in greater detail. Now today we will solve some of the most challenging questions related to sequence and the series. And to begin with, but first I recommend that for those of you who didn't watch part 1, before you deal with this, you watch this video, please try to watch part 1. And let us begin with question number 1. Here, question number 1 says, consider the sequence given as -2, 0, -2, 0, -2. Which one, or and so on, this is which one of the following can be the general term or the nth term of this sequence, provided that n is an element of natural number. Now to solve this question, you have two options: either to formulate the general term, or by just trying for some n's, for some n natural number, each of the general term indicated in the four choices. In A, the general term an is equal to -2 to the power of n. In B, an is equal to -1 to the power of n plus 1. In C, an is equal to 2 times -1 to the power of n. And in D, here as you can see, an is equal to -1 to the power of n minus 1. And therefore, now to formulate the general term, first observe the terms of the sequence. As you can see, the first term is -2, and therefore what we have to do is simply write -2 as -1. Let me choose the marker. -1 here, -1 and -1. Write -2 as such, and then put an in front of these two. Here, suppose this is our an. Now for this term, for this general term to give us these terms, the terms of the sequence, what we have to do is we have to put somewhere here n as an exponent. If I put n as an exponent here, -1 the power of n minus 1. When n is odd, -1 the power of odd number gives us -1. When n is even, -1 the power of even number gives us +1. And therefore, in that case, when n is odd, it gives us -2. When n is even, it gives us 0. And therefore, it gives us the general term, simply gives us the terms of the sequence. Now let us check whether this is actually the general term of the given sequence. Now suppose our n is equal to 1. If our n is equal to 1, -1 the power of 1 gives us -1. -1 plus -1 gives us -2. It is correct. And when n is equal to 2, -1 the power of 2 gives us +1. 1 minus 1 gives us 0. That is also correct. When n is equal to 3, then -1 the power of 3 gives us -1. -1 and -1, when added, the sum of the two gives us -2, and so on. Therefore, now the first option is to formulate the general terms as such, or if you are unable to formulate the general term as such, assuming that you are sitting on the entrance examination and suddenly this particular question appears, what you have to do is you have to check each of the general terms or the nth terms given in choice A, B, C, and D by for simply n is equal to 1. For n is equal to 1, and n is equal to 2. Let us check what will happen if our n is equal to 1. The general term in A gives us, if our n is equal to 1, minus 2 the power of 1 gives us minus 2 itself, minus 2. When our n is equal to 2, minus 2 the power of 2 gives us positive 4. Positive 4. Now, the first term coincides with the first term of the given sequence. It is right. But the second term of this general term is not 0. It doesn't give us 0, but it gives us 4, and therefore it fails to be the correct general term of this sequence. And therefore, put this one be x. And again, when our n is equal to 1, here the general term indicated in B gives us minus 1 the power of 1, which is minus 1. Minus 1 plus 1 is equal to 0. It gives us 0. And therefore, the first term, A1, doesn't give us minus 2, and therefore it fails in the first check. And also, let us clear this one. Let us clear this one here. The general term indicated in C also gives us something like this one. These terms. This general term gives us, when our n is equal to 1, minus 1 the power of 1 gives us minus 1. Minus 1 times 2, it is minus 2, which is actually the first term of the given sequence. But when our n is equal to 2, then minus 1 the power of 2 gives us positive 1. 1 times 2 is equal to 2 itself. Therefore, the second term is not equal to 2, and therefore this also fails to be the correct general term. And the only option left for us as an answer is D. D is going to be the answer, which is the general term that we already formulated here. Now, to see the terms of each of this one, here the terms of the general term indicated in A are minus 2, 4, minus 8, 16, minus 32, and so on. And therefore, that is not the right general term for the given sequence indicated here. And in B, the terms are 0, 2, 0, 2, and 0, and 2. But the terms of this sequence is minus 2, 0, minus 2. And therefore, this is also X. And in C, as you can see, the terms of An is equal to 2 minus 1 the power of n are minus 2, 2, minus 2, 2, and so on. And it is not equal to the given sequence. And in D, the terms are minus 2, 0, minus 2, 0, minus 2, and so on. Therefore, the correct answer should be D, the one found in D. The one found in D. Now, if you have any question regarding this, how we solve this one, then please leave comment in the comment section of this video, please. Now let us see question number 2. Question number 2. What does question number 2 says? Suppose again this question appear on the coming national examination. Here the question says, which of the following relation holds for the sequence minus 10, minus 3, 4, 11, and so on? Here in choice A, An is equal to n minus 1, minus 8. And B, An is equal to An minus 1 plus 7. And in C, An is equal to An minus 1 minus 7. And D, An is equal to An minus 1 plus 8. And now, the question is, which one of this relation is clearly gives us, which one of this relation clearly true about the given this sequence, the given sequence. Now, the first thing is, we have to check whether this sequence is arithmetic or geometric or neither. Now we defined an arithmetic sequence as a sequence in which the difference between the consecutive terms is constant. Then let us check. These are successive terms, and these are also successive terms, and these are also successive terms. And therefore, now let us check whether this gives this sequence is an arithmetic progression or geometric progression or neither. The first thing is subtract from this term minus 10. Minus 3 here, minus 3, minus 3, minus 3, minus 10. We are going to check whether the successive terms of the sequence gives us a constant number or not. Here, minus times minus, as you can see, is positive. It is therefore minus 3 plus 10, and the result of this one gives us 7. And similarly, again, we use these two, and let us check the difference between these two terms. 4 minus 3. What does it? Now the bracket is required to separate the two minuses. Minus times minus gives us plus, and therefore the sum of the two, 4 plus 3, gives us 7 again. Okay, this is about to be an arithmetic. Again, let us check the difference between 11 and 4. Here, this is obvious. 11 minus 4 gives us 7, and therefore this sequence is an arithmetic sequence or arithmetic progression. It is arithmetic progression without any doubt if the sequence continues like that one. Therefore, we call it an arithmetic progression. Now, one thing that we know again in an arithmetic sequence, the difference between successive terms is constant, and therefore, now let us check here. an minus 1 must give us the common difference for all n natural number. For all natural number n. Here, this must be equal to d. That is obtained from the definition of an arithmetic progression. Now, here, observe that we have in A, we have an minus 1. In B, also an is equal to an minus 1. And in C, an minus 1. And in D, an minus 1. But our common difference of this arithmetic progression D, our D is equal to 7, since the difference of the successive terms gives us 7. Therefore, that's the common difference. And replace D by 7 in here. Since each of the relation given here are given in terms of an and an minus 1, then it is directly similar to this one, and therefore here solve for an in here. What is an? An is equal to move an minus 1 to the right, please. Here it has minus, therefore when it moves to the right side, it becomes positive an minus 1 plus, an minus 1 plus d. It becomes like this one, plus d, where d is a common difference. But we know that the common difference is 7. None of this one, here, the one in A is minus 8, and therefore this cannot be an answer. The one in D is also given as plus 8, and therefore it cannot be an answer. Now, the probability of answering this particular question is 50%, since we are left with two choices only. And which one of the two? Simply replace D by 7, and therefore here when our d is replaced by 7, then it becomes an is equal to an minus 1 plus 7, an minus 1 plus 7, where our common difference is 7, and therefore the right answer should be the one in B. If you say this one, then you get a point here, provided that you were sitting simply on the exam and suddenly this particular question appears. And now here, note that the sequence is an arithmetic sequence with the common difference d is equal to 7, and therefore in an arithmetic sequence n minus 1 is equal to d, an is equal to an minus 1 plus d, and therefore the answer should be B. Okay, let us see question number 3. But before, let me clear this one. Actually, I can clear it later on, but let me do it right now. Okay. This question was taken from the previous entrance examination, and I hope something which is similar to this particular question may appear on the coming entrance examination. Okay, let us come to question number 3. Question number 3, as you can see here, it says let an is equal to n plus cosine n pi, where n is equal to 1, 2, 3, and so on, be the end terms of a sequence. Then which of the following is true? That is what the question says. Here in A, the fifth term is 6, and in B it says the 10th term is 9, and in C the seventh term, the sum of the seventh term and the 8th term is equal to 15, and in D the difference of the 7th term and the 6th term is equal to 1. Let us see which one of these choice gives us true. Here, note that cosine n pi, as you can see in this circle, cosine n pi is equal to minus 1 if n is odd. If our n is odd, then cosine n pi gives us minus 1. If our n is even, cosine even times pi is always 1. Having this in mind, then let us deal with this one. What is the fifth term? The fifth term, our n is 5 in this case. Our n is equal to 5. Our n is equal to 5. What is a5 then? And therefore our a5, just replace n by 5. a5 is equal to, just put n in it's 5 in n, replace n by 5, which gives us a5 is equal to 5 plus cosine of 5 pi. We say 5 is odd, and therefore cosine of odd number times pi always equal to minus 1, and therefore then the sum of this one and the minus 1 will give us the following number: 5 plus, put it in bracket please, minus 1 here, because cosine 5 pi is minus 1, and then 5 plus minus 1 gives us 4. It is not actually 6, and therefore this is false. This is not true. Similarly, the 10th term I have already done here. the 10th term, when our n is equal to 10, a10 is equal to 10 plus cosine 10 pi. 10 is even number, cos 10 pi gives us 1. And therefore, 10 plus 1 gives us 11 here. 11. It is not 9 as indicated in here. Therefore, this is also x. Our probability of getting the answer becomes now exactly 50%. Observe that when our n is equal to odd number, such as this one, 5, then it reduces to 4. 5, a5 gives us 4. But a10 gives us 11, which means an gives us simply from by observing this formula, it gives us n minus 1 if our n is odd, and it gives us n plus 1 if our n is even. And therefore, now a7 is odd, and therefore a7 should be what? A7 must be equal to 6, because 7 minus 1 is 6. A7 is 6. And A8 is even again. A7 is odd, and therefore odd reduced by 1, which is 6. And A8 is even number, and therefore when our n is n odd, here put it n odd, n is odd, I hope, just assume, take it as odd, and n is here even, just when our n is even. I am practicing actually this one. I can improve gradually this one. Here, when n is equal to 8, then this becomes 9, and therefore a7 plus a8, a7 plus a8 gives us what? It is a7 is 6, and the plus a8 is 9. 9 plus 6 gives us 15, which is 15, and therefore C is the right answer. C is the right answer. Now here I have done here the answer. A7 is equal to 7 plus cosine 7 pi, which is 7 plus minus 1, which is equal to 6, and A8 8 plus cos 8 pi, 8 is even, and therefore the cosine 8 pi gives us 1, and therefore 8 plus 1 gives us 9, and the sum of the two terms is equal to 15, which is the right answer. This is the right answer. Therefore, this is actually X, because A7 is 6, A6 is 7. This becomes 6 minus A6, because it is even, therefore it gives us 7. 6 minus 7 gives us minus 1. It is not 1. It is not positive 1, minus 1. Therefore, this is also X. Okay. Next, let us see question number 4. Question number 4. Question number 4 also directly related to actually the entrance examination. And therefore we need to see to understand what the question says and how to solve the question. He leaves this one as this. Okay, question number 4. What does it say? Question number 4 says the nth term of the sequence 1 minus 4 9 minus 16 and so on is, that is what the question says. As I said, check whether this sequence is arithmetic or geometric. For this to be arithmetic, the difference between successive terms must be constant. Here -4, -1, -5, and 9 minus -4 means it is 13, which is not arithmetic. And let us check whether it is geometric or not. Now, the ratio of successive terms must be constant in geometric progression, but here -4 divided by 1 is -4, but 9 divided by -4 is not equal to -4, and therefore this is not also geometric progression. Now the only option left for us is either to formulate the n term or to check for some of the n's, for some n, particularly when n is equal to 1 and when n is equal to 2. Let us check each of these. Here, as you can see, the terms of A, the general term indicated in A, are -2, 4, -8, 16, -32, and so on. Let us check. When our n is equal to 1, -2 the power of n gives us -2 itself, which is not equal to 1. The terms of this sequence is 1. The first term of this sequence is 1, but here this general term gives us -2. Therefore, this cannot be the right general term. And in B also, the general term n is equal to -1 the power of n times n squared. And then let us check for n is equal to 1 and 2. When our n is equal to 1, here we have -1. -1 the power of 1 gives us -1. And again, 1 square. 1 square is equal to -1 times 1 gives us -1. And therefore, this can also the first A1 gives us -1 here, but our first term in this sequence is 1, and therefore this cannot be the answer. Let us see. Observe here, -1 the power of 2n is always +1, and therefore this sequence is equal to n squared itself. It is equal to n squared. And then try by substituting n here by these numbers. Since our n is natural number, then check for n is equal to 1, for n is equal to 2, and for n is equal to 3, and so on. When our n is equal to 1 here, 1 square gives us 1. Exactly, the first term is correct. When our n is equal to 2, 2 square gives us 4, which violates this one, which is contrary to this one. Here, the second term is -4, but the second term that we get from this general term is +4, and therefore this cannot be the answer as well. The only choice left for us to answer this question is the one indicated in D. If we check this one, when our n is equal to 1, 1 minus 1 is 0, -1 the power of 0 is 1, and the 1 square is also 1. 1 times 1 gives us 1. When our n is equal to 2, 2 minus 1 is 1, -1 the power of 1 is -1. And here 2 square, it is 4. 4 times -1, it is -4, and so on, and so on. Let us see the terms of each individual general n terms given here. The one that is given here in B, in choice B, the terms of general term indicated in choice B are -1, 4, -9, 16, -25, and so on, which is not equal to this sequence. And the terms in general terms indicated in C, as you can see, gives us 1, 4, 9, 16, 32, and so on. It is not equal to the given sequence. The terms in D, in the general term of D, gives us 1, minus 4, 9, minus 16, 32, and so on. Therefore, the answer is D. Now, this is the end of part 2 of this video. Next time, in the next part, in part 3, we will see another question related to sequence in the series, which are hopefully will appear on the entrance examination of grade 12. Until then, see you. Bye bye. Please subscribe and like and comment on this video.